Hello everyone, welcome to the 9th session of our Pixopalooza. Today we're going to be talking about the Pixo-Gateway, a new product that allows Pixotope Engine to be integrated into existing workflows using Vizgraphic playout systems. We're going to show you how the Pixo-Gateway fits into your existing environment to create a single graphics control playouts interface. We're going to show you how to build control templates using plugins, and we're going to demo the blueprints needed to tie this all together. If you have any questions for today's session, please submit them off to the side of the screen and we'll answer them all today at the end of the show. So who am I? My name is Aaron Thiel. I'm a special projects engineer with the Future Group based out of the United States. I've been developing systems to automate graphics playout in control rooms and remote events for over 20 years. My first 3D character generator was actually the Pinnacle Deco with Rocket going back to 2001 on ESPN. And I've been integrating automation systems for augmented and virtual solutions since 2008. Joining us later will be Frank Vedvik. If you've been following our Pixopalooza sessions, you'll be very familiar with Frank. He's hosted quite a few sessions and he's very knowledgeable about building content in the Unreal Engine. So let's get started. What is the Pixo-Gateway? As I said, the Pixo-Gateway integrates Pixotope Engine into your existing Viz content pipelines. It allows you to add the best-in-class real-time rendering capabilities of Pixotope while also working in a singular environment that lets you continue to leverage your existing investments into training, graphics hardware, and software that you may already have. The Pixotope Gateway creates a system for pages and templates that you have in Opus, Pilot, Trio, or Multiplay to be able to send commands directly to a Pixotope engine. Your operators can continue to work in these applications they already know. We haven't changed their workflow, and how they manage your rundowns all stays the same. The Pixotope Gateway also allows your operator to have Viz pages and Pixotope pages coexisting in a single rundown. You don't have to have separate systems for one engine and another system for another engine, or popping between different control applications within one screen, or even jumping back and forth on a KVM to go from one control system to another. So this is your typical Viz graphics pipeline. You could be your single operator running your Trio show. You could have a distributed system for your newsroom running Pilot, or a Multiplay to control multiple engines for your studio, or you could be running a whole production from a single box in Opus. It doesn't really matter for the Pixo Gateway what you're using, because all these systems control graphics in the same way. An artist will build their scene using Vizrt and create a template. The template becomes a page, and when the page is played out, the information is sent to the media sequencer. This communication is the same if you're a small digital media studio with a single engine, or maybe you are a high-profile show that has 8 engines in the control room and enough studio support engines to fill up the 114 monitors. For Pixo Gateway, this doesn't matter. Whatever your environment is, it doesn't have to change. We don't have to reconfigure anything. It really just helps get Pixo Gateway into your workflow. So what is Pixo Gateway? It's a communication service that runs in a virtual machine somewhere on your network. The Pixo Gateway connects to your Viz media sequencer and receives the commands sent to your Viz engines. To filter these commands to make sure that the Pixotope engine receives these instructions, we add a channel to the output configuration called Pixotope, and any pages sent to this channel will be received by the Pixo Gateway from the media sequencer. Now, this doesn't interfere with the communication between the media sequencer and your Viz engines, and everything there stays the same. Your Pixo Gateway is a VM, and it can be installed anywhere on your network as long as it can talk to the media sequencer and your Pixotope engines. You can put it on your playout control computer, you could put it on the media sequencer server, or you could even put it onto your Pixotope engine. The performance requirements are very low, so there's no impact to really having it on the same computer. And actually for this demo today, I'm running a Viz Graphics Hub, media sequencer, Trio, Viz Artist, a Viz Preview Server, the Pixotope Gateway, the Pixotope Data Hub, and the Pixotope engine all on a single laptop. So performance really isn't an issue here. So after the Pixo Gateway receives these commands from the media sequencer, it sends them to your Pixotope Data Hub, which forwards these commands to your Pixotope engines. You can have one engine, you can have two engines, you can have as many as you want. And based on your configuration, it will determine which engines receive these commands. For instance, if you have an installation with multiple tracked cameras for a virtual set, you can now trigger the same effect on all your engines from one place. Your templates can even be built to send instructions to a Viz engine and a Pixotope engine simultaneously. So if you have a Viz engine configured as an input source for Pixotope, you can trigger a transition effect on the insert graphic while also triggering some reveal animation of geometry for a monitor in a virtual set, and these two effects will seem coordinated. Also, the Pixotope director functionality isn't interfered with in any way by having the Pixotope Gateway. So any existing content you have in Pixotope, such as scenes and control panels, will all function the same way they always have for you. For data, you have lots of flexibility getting automated data into your Pixotope scenes. You can follow the traditional Viz methods of having your team, your production team entering content in their newsroom system, or your operator in Trio can build out their tab fields. All this stays the same. Even if you have custom data integrations using Viz scripting, that can all be repurposed for Pixotope scenes. You get to choose whatever method you want to make the most sense. If you need to, you can even use direct access between the Viz or between your Pixotope engine and web APIs, SDKs, whatever you need to get content into your scenes. So what's involved for an artist to build a template for a Pixotope scene? Your designer will build a dummy page in Viz Artist. That's an empty scene with very limited functionality. It does need to have objects for all the fields you want to be exposed for editing when you create your pages. And then your artist will use native Viz control plugins to designate these tab fields to create the tab field list. These are the same control objects and plugins that they're currently using in your Viz workflow, and these will all work with Pixotope. There's no changes or custom plugins needed. When the page is played to air, the tab fields and associated data are received by your scene in Pixotope and trigger an event in your blueprints. This data is a delimited string that you have to parse in your blueprints, and we'll show you how to do this in a little bit. Frank will help us with that. And you can use these triggers to update a text mesh, trigger lighting changes, animate camera moves, or reveal set elements. You're really limited by your design and your imagination on what you want to do with these triggers. So let's jump into the Pixo-Gateway and Trio. Okay, so here we have our ray tracing scene running in Pixotope. And up here in Trio, those of you familiar, you'll see my template list. We've built some templates already. I have camera triggers. So this is a page, no text fields. It has a text layer in it for showing the art or your operator what animation is going to happen, that this is going to take us to a pre-built camera position 2. Let's trigger that. So as you can see, our virtual camera moves inside of our virtual world. We also have pages that can do lighting changes. If you want to script them up, we're changing our lighting to give us a different atmosphere. So now it's in blue, and we can also change it to red. You can see in our pages in the templates, we have a material in Viz that we're using to trigger these changes within our scene. Let's put everything back to white now. We have another type of page for our AR elements. So these scenes are a little more complicated. They have some text layers, but really still very simple. We have, you can see in our tab fields, left image, right image. So we're taking headshots, loading them in our scene, the candidate names, number of votes received, and the state that we want to reveal. So let's play this one out, and we'll see the element come up from the floor. And we can also move in on it closer as we watch it be revealed. And there we go. So let's show you, we'll take this one out. We'll edit the next one. We'll take Utah. So we have, again, our talent headshot. We can change the texts for their names. You change the number of votes to whatever, updated information. Whoops, that's a little low. Let's see, and we'll save the image. McDonald, change his, and we'll stay with Utah. Save. Take that page, and now we'll see the element come up and play with the updated values that were typed in by the operator. All right. It's pretty straightforward things that we've seen so far. Let's go back to our wide shot. Now let's dive into Vizrt Artist to see how these templates were built. So here's my project in Artist. Let's load our camera page. So it's a very simple template within Viz. It has just one control object where we've identified it as a camera mover, a description, the layer identifier that we're using. So we're taking the transition logic and using that instead of doing transitions, using it as a trigger in our blueprints. We've identified as camera. So now in our parser within Pixotope, this will trigger a camera move. And I'm using the state identifier to tell us where to go. So camera 1 tells us to go to position 1, which is a closer view of the stage. I have 4 of these, one for each of the camera positions that we predefined in our scene. This is the lighting change page. Again, it's very straightforward. I have my control object. I've defined it as a layer type of lighting to trigger a lighting change in the scene. And we're using the blue material in our material list, that you can see here, to change my lighting from white to whatever material color that we picked here as blue. And we've added a text layer just to add that to the scene in case your operator might be colorblind. We've had that happen in some of the operator pools I've worked with where they could use that extra information. Next template that we have is the AR elements that we showed before. These are a little more complicated. We have our control object for the page itself. We have defined it as an AR results for the election, and we have a state identifier playing it in. We have our background scene. And if we look at the page itself, all the control objects associated, we'll see all those tab fields that we saw before in Viz Trio. So the left image, left name, left number of votes, the right image, right name, right number of votes, and the state. So the state, again, is typed in, and that is filtered on the playout side in the Pixotope engine to determine which 3D geometry flies up and drives the animation for the reveal. I'll go back to our server. And it's really straightforward. When your artists are building these dummy pages, nothing really changes for them how they do this. They still use the same objects in their scene tree, the same plugins, the same control objects to build these dummy pages. And when you play them out, we're just directing them toward the Pixotope engine instead of our Viz page or Viz engine. So let's build one here quickly just to see how quick it actually can be. I'll close that. I'm gonna make a lower third. We'll put a lower third on the stage. So it's gonna be 3D text, and that will allow us to put up either, maybe the name of our talent or coming up, that kind of stuff that we can do in 3D space. We'll add a couple groups. Let's child this one. We're gonna add a control object. Plugins, control object. And we will define this as lower third. Turn on our transition logic. So now we're going to use our layer identifier to let our engine know what type of a message it is in the state. And I'll put in my background page, which is really only used for the preview server. On our second group, we're going to add a font to our scene. There we go. We'll give it a material as well so we can see it. There it is. We'll center it just so it's in the center of our screen. And then we will add a control text so that it can be updated remotely. See a control text, drop that on there. We'll define that as well. So our field identifier. So this is the field within the template that we want to be updated. So we only have the one piece of text in this example. We'll call that lower third as well. And you know, for the description in the tab field, we will say talent name. And save that into our project. And save. And that's it. That's about as straightforward as you can get. We'll go back to our trio. No, I don't want to reload any of my existing, but I do want to go in using the import, pick my project, and import the page I just made. And then we can, you know, now I don't have that functionality in the scene yet, so I'm going to turn it over to Frank, who will show us how we you know, connect this all together using blueprints.
All right. Hello, everyone. My name is Frank and I'll be showing how to build a little sample blueprint or that we can make a template out of and reuse to take in different kinds of data from Pixo-Gateway and Vizrt. So let me just go ahead here and share my screen. Let's see, I'm just going to have to, there we go. And we are going to be sharing, there we go, terrific. So now we are working in my local copy of the same project that Aaron has been showing us so far. Now I don't have this installed on this machine, but I will simply be using a sample string that we extracted from Pixo-Gateway on Aaron's machine. So we're just going to go ahead and jump into a new scene and get started. Before we get too deep into this, it's worth pointing out that what we're doing now is just showing how you would go about building a blueprint designed to take in Pixo-Gateway data strings from scratch. You obviously shouldn't do this from scratch every single time. You should have a library of templates and pre-made sort of master copies that you then make instances of every time you were doing a different production. This is just so we get a good, deep understanding of exactly what's happening under the hood in terms of making Viz work with Pixotope. Okay, so let's actually do this in my dev folder. Second level, no. Here you go. And let's dive straight in. So the particular blueprint we will be making now is simply going to take in a payload from Pixo-Gateway. We are going to use that payload to drive a Pixotope 3D text element. For instance, to set maybe a title card or set the name field in a bug or to give a name field for our talent. The use for having 3D text in your scenes is obviously many and versatile. Just go ahead and close these distractions on the side here. There you go. Okay. So we are going to be working with an animated text mesh, which is proprietary for Pixotope. It is our solution for taking in any kind of font and use it to build the dynamic 3D text in real time. Then we are going to start doing some blueprinting. We're going to right-click and create a new blueprint. We're going to call it BP Text Handler. And we're going to dive straight in. So now I don't, as I just mentioned, I don't actually have this on this machine, but we can still feed in the same copy of the data string that Aaron is going to receive later. Now we already had something blocked out. So what we're going to be receiving is a payload of data where all the different lines of data has been combined into a single string, and it's going to look something like this. This particular payload is for setting our talent name. We can see that we have 2 lines separated by a comma in the middle. And then in each of these lines, we have a column separating the actual identifier for the data on the left side, describing what the purpose of the data is. We see here that for this line, this is a talent name. On the right-hand side, we have the actual data that we wish to be extracting and using within Pixotope. So let's go into our event graph and start building this piece of logic. So we're going to go ahead and first of all create a few variables in order for us to be able to reuse this blueprint forever. Because again, it's not efficient to always build blueprints from scratch. You definitely want to have a library that you can just instance and quickly get up on air whenever you are building a new Pixotope scene. First of all, we're going to need the actual text element that we wish to change. Let's make sure this is going to be an animated text mesh reference. Perfect. The next variable is going to be a string. The purpose of this is to allow us to quickly change the purpose or what the blueprint is listening for on the fly without having to go back into the blueprint editor every single time. So we're going to need a public variable that can change on every instance of the blueprint called identifier. We are also going to need a label, which is going to tell us which particular template does this blueprint listen to. We are going to need nothing else, actually. That's just about it. So how do we actually receive messages from Pixo-Gateway? Well, in order to receive the messages, we need to have an event node called a data receiver, which listens for whatever is passed to us through Data Hub from Pixo-Gateway. In order to access this node, we need to reparent our blueprint using the file reparent blueprint logic. This can be done on any blueprint. If you have something you already made for Unreal or Pixotope, you could also reparent that to work with this data subscriber parent. Now that we reparented to data subscriber, we can see at the top right, we have a new parent class. This gives us a few different pieces of functionality. I can now select the blueprint itself and give it a sender name, which is basically which sender are we supposed to be listening to. This allows you to have different blueprints listening for different particular instances or hosts as you're running live. I'm not really sure when you would use that, but it's important to know that this functionality exists. Then we're going to build the actual listener logic. So we are going to need a receive data node. And this is what is going to get triggered whenever Pixo-Gateway sends us a message. We're going to receive the data payload. The template is going to come, the name of the template will come in as a label, allowing us to identify which template are we currently using. And then we can do a switch operation based on what the label is. If the label is, say, election graphics, then we can take the payload and pass it on to our election graphics blueprint. If the label is lower third, like we expect it to be here, then we can instead take the payload and pass it to our animated text mesh blueprint. In this case, I will not use a switch because this particular blueprint is only going to deal with text element. So I'm going to use an if statement. Let's go ahead here. And the if is going to check if the label is the same as our identifier. No, sorry, our label, the expected label that we will be putting in the blueprint. So what we're doing here is we're checking if the message we're getting is relevant for this blueprint by just comparing the label that we receive with the label we are expecting to get. If this condition is true, then the blueprint will be allowed to move on. So if this condition is true, then we're going to just go ahead and make a new event below here. We're going to parse the payload or parse the data. And the data is going to be the data we receive from the received data node. Not to access this, you have to first compile your blueprint. Interesting. Not sure why. Oh yeah, the reason I wasn't able to pull out from data is because I forgot to add the input. Because with this event, we also expect to receive the actual payload, which is a string. So now I can take this data payload and just pipe it directly into this next function. Select this, hit C for comment, and just say that this is going to be our C data logic. But since I don't actually have Pixo-Gateway and Viz running on this machine, I will make a new custom event directly above this called debug, which is what I'll be using to feed in sort of my manual copy of the same payload. This is also going to have a input string, and this is going to skip the receive data logic, and we're just going to go straight to the parse payload functionality. Make this nice and red, so you know for later this is debug. It's always good to comment and make sure your blueprints are organized and readable, because there's no guarantee that the next people that's going to come and work on them is going to be you. Next is the parse payload. So now we actually need to take our data field and clean it up a bit. Let's inspect the data in question. So we need to find the line that has the particular identifier we're looking for, in this case, talent name. It might just as well have been channel or any other bit of line if this was a different blueprint. We can see that we have a bunch of quotation marks that we want to get rid of. Then we need to split our single line up into an array where each element is a different line. You can see that the lines are segmented by a comma. And then lastly, we need to split up each line based on the column, where the left side will be the identifier and the right side will be the actual data. So let's do that right now. So first, we are going to do a replace function on the payload. We are going to find every quotation mark and replace it with nothing, which basically is just going to go ahead and get rid of all these quotation marks. The next thing we need to do once this has been done is cut our single line payload up into array elements by parsing using the comma as the delimiter. This is a pretty standard operation. We're simply going to do a parse into array function, and we're going to use a comma as our delimiter. And then once we have this array where we basically have a long list of elements, each field in the array being a separate line, we are going to throw this into a for each loop so we can do a piece of logic on every single line. This will allow us to search for our identifier in every line in the array until we find the data we are looking for. So now after we've done this parse operation, we're basically left with something that looks more like this, 2 lines or 2 entries of data. Then we're going to take each element, we are going to split it into 2. We're going to split it using the column. Then, as you can see here, we now get the output left string and right string. These strings are going to be left string, the identifier, and right string, the actual data. So then the only thing we have to do is check in the left string, does the left string contain our identifier? We're going to check if that is true. And if that, as a matter of fact, is true, then we can assume that the right string is our actual payload. And we're going to pass that to one last custom event called set text, which is also going to have a string input, which is going to be the phrase. So here, from our right string, we're going to go ahead and set the text. Let's just go ahead and connect that. And now we can Again, clean this up, because when you build these templates, you'll be doing it once and you'll be reusing them hopefully hundreds, if not thousands of times. So it's always good to make sure they are as clean and organized as possible. There we go. We now parsed our data. The last thing we have to do is take this phrase. We will get a reference to our 3D text. We are going to find all the parameters in our 3D text. And we're going to head and just change the members. So set the members in our text mesh parameters, which is basically how we're able to pipe in new data or variables on the fly. Notice that in this node, we could do more than just set the phrase or whatever the text is supposed to say. We can also change alignment, font, glyph offsets, animation values. We can dynamically change the materials of our text. And all of this can be driven through Pixo-Gateway and from Viz. There really is no limit on what you could drive from this. You just have to build the blueprint logic to receive and do operations based on the data. Let's give this a nice, warm, summery green color. So I probably won't be going outside much in the next few months and seeing much green at all. Good. Just gonna have to make do. Very good. The only thing I have to change now is I change the input phrase, or the name of the input string here to phrase, but that has not been updated over here. So let me just go ahead and remake this node so it doesn't complain. What did I call it? I call it set text, that's why. Set text, there we go. Now let's go ahead and give this a spin, compile, save, and let's try it out in our scene. We talked about the fact that you definitely don't want to build this every single time. You would want to make a library of these different blueprints. And now we're going to see why that is. We're actually going to go ahead and take our animated text mesh and just parent it to this blueprint. And then we're going to go ahead and make a copy over on the right-hand side. So now we can see we have two copies of the same blueprint and two different text meshes. We're going to select the left blueprint, and this, as you see here in the details tab, we have some input fields. These input fields are the variables we made that we exposed and made public, and these are the only pieces of data that we should need to change in our scene in order to make our blueprint listen to and do different things. So the left blueprint is going to use the first text mesh in our scene. The identifier is going to be talent name. And the label is going to be lower third. On the right-hand side, this is going to be talent profession. So we see a different identifier. And the label is going to be lower third. Because this is still going to be a part of the lower third, so it's going to be listening to the same page or same template, but it's just going to use a different line from the payload. Let's go ahead now and simulate this. Let's just put our blueprint over here as well. Let's scale this down a little bit so we can see everything. This is just in the unlikely event that this doesn't actually execute as intended. We can see here where the execution stops. Let's also make sure that we are listening to the correct text handler. There we go. All right. So now the last thing we're going to do is open our output log, because we don't have this on this machine. So we just have to fire this data manually using a call event function. So KE for call event, asterisk as a wildcard. We just want to simulate Pixo-Gateway. We just want to call this event on every single actor in the scene. The event is going to be debug, not data receiver. And, oh, that was not correct. And we are going to just pass the same bit of data that we later on will be receiving from Pixo-Gateway on our machine. So let's go ahead and enter, and we expect the left string to update. There we go. And I can see now that neither of these behaved as intended. You can actually see that both of these set the last string to be the active one. Let's go ahead and give this a quick peek to figure out what just happened. You can see our field text is set correct, our identifier is correct, our label is correct. Go directly to parse payload. Our delimiter is correct. This one is correct. Here's the problem. So we have this beautiful parser. We're checking if, so here, we're looking for identifier. We probably find the identifier telling us whether we have found the correct line of data. The problem is we never actually do anything with this information. It kind of stops here. I never actually check if this statement is true. We need an if statement to allow us to say that if this is not true, then we do not execute the set text logic. We do not update the text. So we were supposed to stop here on the last line because the last line has identified a channel, which is not the line we are looking for. Let's try this one more time. Simulate, hit up, hit enter, and there we go. The right text does no longer change because it never passes its identifier as valid. On the left side, we now have our name field. You can see that if the template were to change, if the payload becomes different, so does the text. It really is quite reliable and robust at this point. If you wanted to change the right text field, which is listening for the title and profession identifier, we just need to ensure that we have that particular line in our data. Aaron's profession is not Aaron. There we go, perfect. So now we built a template from scratch. And as you can see, we no longer have to jump into the blueprint every time we wish to work with it. We can just recycle this in every single scene by just dragging it in from our content browser. Now that we looked at this, let's just take a cursory glance at how this logic works in the studio level that we've been looking at before we hand this back to Aaron. What is this level? I don't want to say that. That seems sketchy. There we go. So now we're back in our beautiful Pixotope studio here. So we're going to take a look at some of the blueprints that we were just interacting with, and we're going to notice something interesting. Now, there's nothing stopping you from making every single blueprint in your scene a data listener. You could have each blueprint only caring about itself and nothing else. But this particular scene was already built before we decided to integrate Pixo-Gateway in this particular project. You can see that we have logic like, for instance, let's not select everything. There we go. We have a blueprint for light handling. Let's open it. This is the blueprint that Aaron showcased that changed the scene lighting from white to red to blue. It has an input custom event where we receive a color, which is a linear color structure, and the intensity, which is how bright is the light supposed to be. And then we do some logic where we tint our global illumination in a post-process volume towards these new values over a timeline. So over a period of time, we blend from A to B. But there's no data listeners in here. We can't actually identify any Pixo-Gateway related logic. And if you look in the top right, this is not parented to the data handler. If we will go ahead and look at some other piece of logic, for instance, the camera manager, you'll see the same thing here. We have some logic to do a switch based on an input integer between 1 and 4, where we jump between 4 different predefined camera positions. And then we switch to that camera using the Pixotope coordinator to do a switch to camera operation for 3 seconds. But this again has no data listener logic. So where is this actually called? Where does this command come from? Well, for this scene, instead of having to go in and start changing all the blueprints we wanted to interact with, we instead opted to make a singular master controller. This might not necessarily be the best workflow, but it's workflow we chose to use here. It's Pixo-Gateway opens a lot of doors to kind of build your scenes in whichever way makes the most sense for you. For us, it made most sense not to change the majority of our blueprints, because the source project was not originally intended to be used in Pixo-Gateway, and we might want to refresh the rest of the data without necessarily keeping all of this data handler logic in the scene. So here we can see that we have this chunk that simply receives the data, same as before. And this is the same kind of parser that we just built. We've taken the label and we do a switch on string operation instead of an if statement, because here we don't want to check if we are matching one particular string. We actually need to know which string are we receiving so we can do the correct data. So depending on the template, we can see that we have multiple branches to do different pieces of logic. Some of these are calling exterior blueprints, like our light handler or our camera controller. For instance, the camera 1, 2, 3, 4 templates, which call change position with value 1, 2, 3, 4, these nodes here. And these are over here on the side. And all that these pieces of logic do is just pass this command on to the different blueprint for handling our camera. Then we have our election graphic, which is a lot more complicated, has a lot more things going on for it. That is further being parsed down here. It's a pretty complex piece of logic. It has these to handle the votes, the delegates, the state, and then it passes all of this on to the election graphic, which is again a separate blueprint. So this is just another example of how you can streamline this into a single master controller if that seems more reasonable for the kind of production you wish to do. There's no problem using multiple event received data events in different blueprints, but this is one way to ensure that you can see everything you're supposed to be listening to in one single interface. Lastly, just at a cursory glance, the actual election graphic is a pretty complex blueprint. It's not very complicated, there's just a lot of segments and steps happening. So you can see here, if we open the election graphic, here in the top left corner, we receive all our data. We receive our Republican votes, our Republican names, our Democrat votes, our Democrat names, and as well as the current state that the election data is supposed to represent. And then we execute through the logic. We animate in the map, we highlight the state, and we do a bunch of steps where we just animate different parameters and variables to play the full election graphic. But the actual data handler logic is just this chunk up here, where we just receive different bits and pieces of data. So I hope this all made sense. But again, if anything was unclear, please ask questions. We'll get to them at the end of this session. But for now, I'm going to go ahead and hand this back to your colleague Aaron, who's going to wrap up what we have to present today. Okay, over to you, Aaron.
Okay, thank you, Frank. I'm going to show you now some of these additional control pages that we have. So we added in, let's see, we'll fly in here first to get a little closer. We have an element to reveal a video wall. And you can see it gets revealed. We'll toggle on a video. So now our sizzle reel is playing. And we can trigger scene geometry, which now takes us to the upper deck of our studio. If you notice, the video is playing in both places. And we're also blending our camera moves between how we flew into this location and then we followed the physical geometry up to the lower deck, to the upper deck. You can change our video again and go back down. And here you can see as well that that video is still playing in both places. Actually, let's back up a little bit so we can get a wider view of our stage. And so now we'll show off the lower third element that we just watched Frank create. Interesting, now it's not working. Oh. So I'm not sure what happened there. Oh, I know what it is. So when we add the pages to our rundown, again, we've created this Pixotope channel within your trio, your configuration for your outputs. All of your pages have to be sent to that Pixotope channel. If you don't send it there, they go to your Viz engines, and your Viz engine doesn't know what to do with them. So if we take this now, there it is. There's our font. I just want to remind everyone following along that if you have questions about Pixo-Gateway and you want to get a more detailed demo or walkthrough or of the Pixo-Gateway, reach out to your local sales representative. Their contact information is up here on the screen. I'll put it up again later after we get through some of the questions. So within Trio in your Viz environment, through your configuration, when you set up your outputs, you can add channels for your studio, your PCR, whatever your studio environment happens to be. So we've added a channel, Pixotope, and any instructions sent down the Pixotope channel get picked up by the Pixo-Gateway. So that was why when I was running these two pages, I forgot to switch the channel from program back to Pixotope. So those instructions were being sent to the Viz engine instead of the Pixo-Gateway to be redirected to the Pixotope engines. So it's straightforward, just add that channel, assign your pages to go down that channel, and the Pixo-Gateway in your scene should receive all the commands and data packets. For that, I think we'll have to jump into Artist. I do have a template, let's see, pre-existing, where I was playing with scripting. So here is a template, pretty straightforward. Let's rewind it. And we were playing around with creating a timeline that had multiple pause points in it. So if you have some sequence of animations where you want to start triggering something and wait so your talent can do whatever, and then you want to continue and do a continue and do a continue, that's what this timeline does. So if we play it, the state, these are really just commands that I'm sending across to be processed by the engine. And as we continue through each one, continue animation, the progress bar is really there just for my operator, again, to know how far we are through the whole animation. Enter map, select state, show results, and then exit. So our scene, or this template, has a timeline, and we'll scroll into that. Has a couple pause points, and then on each of these, there's a piece of Viz script updating this text field on the screen, and that command then gets pushed through the Pixo-Gateway and received by the engine, and you can process that as you want to do whatever you needed to do at the other end. I did mock up a quick little demo here. I'll go to Artist for a second. Let's see, go back to my server. Let's see, timeline. So this page has a simple timeline. It's got some pause points in it. So if you have some animation within your Pixotope scene where you want to have multiple stages, maybe an initial reveal, your talent talks, you show a video clip or some insert elements maybe in the background, and then it progresses through over the course of your segment. So what this page does is it updates a command string, which is received by your blueprints. And that command string gets sent after every pause in your playlist or in your animation. So when you run your continue, it'll send the next command string. And I've also added here a kind of a progress bar just for your operators so they can see that it is changing as you go. So you see, progress, we just reset. So if our AR element was out there for now, before we put it to air, we want to reset it so that all our old data and information is gone, and we would read loading all of our new content before it gets revealed. So we continue. So now we've entered the map. Our map element pops out on the floor, and the state gets revealed, and then we continue through. State pops up, gets colored, show results, all the data and bar graphs pop up, and then exit. So now the whole scene elements kind of go away at the end. So looking at one of these breakpoints, you can see there's some Viz script here associated with the timeline. So as you go past it, that script gets executed. And you can see we can test all that here. So any script you have in your templates will still work. So if you have a lot of script for pulling data or calculations or whatever you've already done in your environment to kind of build that automation in, all that stuff still works because it's not specific to the engine. It's happening on your user control side. So as long as you're sending that information to the Pixotope channel using your control objects and your plugins, it'll be received by your scene, and whatever associated animations or effects you have will still be triggered. Everything that you're doing in Treo now for your Viz engine graphics should be supported by Pixotope and the Pixo-Gateway. There's really nothing that we're adding. We're not adding any custom plugins or any custom elements to these graphics playout control systems. It's still your native Viz software. So if you want to, export your show, import your show, and move it between machines, maybe there's nothing specific to a Pixotope page that would be lost or not transferred with your show. Again, it's all happening downstream between the Pixo-Gateway and the engine. So as long as you take your show from one environment, bring it to another, as long as your Pixo-Gateway is there, your Pixotope channel is there, all your graphics should play out the same. So again, the Pixotope Gateway, it's network communication, it's TCP/IP packets. So your gateway can be anywhere on your network. It's a VM running a version of Ubuntu. Very low performance. You can put it on the same machine as your media sequencer. You could put it on your Pixotope director machine. You could put it on your Pixotope engine. It really doesn't matter. It just needs to be somewhere where it can get access to your media sequencer and your Pixotope engine or your data hub over the network, because your data hub will send the instructions over to your engines. So the location there is really, it's up to you guys and how your engineering team, the best place you think. But the performance is very low. Again, I'm running this entire pipeline on one laptop. So the performance requirements there are very low. I think that's it for the time we have today. If you have any questions about the Pixotope Gateway, feel free to reach out to your local sales rep for your region, and they can schedule something further in depth so you can get more Q&A time with us and really kind of figure out how this would fit into your workflow that you have now. And that's it. On behalf of everyone at the Future Group, I want to thank you for joining us today, and staying with us and learning about the Pixo Gateway. Again, reach out to your salesperson to get more information about Pixo Gateway so we can figure out how we can help you do high quality graphics. Thanks again.